Good morning, everyone. Welcome to BYJU'S exam prep. So, here we are going to discuss the questions from the textbook of EMFT, that is most popular book for the good number of questions. If you want to practice the good quality questions, then you can refer this book. So, just I would like to tell you that here we are going to start the session with the questions of the transmission line, and along with that we will also follow the questions of waveguide. So because we have four sessions, so I have divided in the four different chapters. Obviously not all the questions could be covered, but I will cover the most of it, like I will cover the most important chapters. We have covered the plane wave propagation. So 70% questions, 70% questions of yeah, plane wave we have covered, and the we are going to cover the questions from the waveguide. And before starting the session, guys, I would like to introduce myself for those who are not aware about me. And this is Saket Verma, and I'm having more than 13-year experience in the field of GATE and ESE. I have done MTech from IIT Guwahati, and I have cracked a different PSU exam as well. These are the area of expertise that electromagnetic system, advanced communication system, signals and system, ICT. These are the Telegram group link. You can join this Telegram group to get the daily dose, important questions, notification update, class notification, PDF, and doubt, etc. So, guys, this is the first question in front of you. I would like to solve this question in the 5 minutes. Diagram A, B, C, D, E. You have to identify that which one of these eight. Go through it once and let me know what is the answer you are getting. Okay. This is representing the unit circle. Okay. This is nothing but the. Now answer this. Yes, are you getting a voice? I found that it was a little bit buffering. So, guys, answer this question. Last 6 seconds left, and nobody has answered yet. So this is sad to see that nobody can solve these type of questions. Okay, so in the if I talk about your Smith chart, right? If I take suppose this one, let me take this one. That would be better. Okay, so suppose if I take this circle and we have some important lines over there. This is a unit circle. Okay, so here we say that it is a real part of the gamma, and here it is the imaginary part of gamma. Okay, now in this point, this is the unit circle, as I said, that is the given point is unit circle. In this unit circle, we made this unit circle for r equal to 0. Okay, for r equal to 0, we get this unit circle, and we have A, B, C, D. Here the points are A, B, C, r equal to infinity, and this point the x equal to infinity. So here in this particular section, the r is 0 and x equal to 0. Point D, r is 0 and j is also x is also 0. So the normalized impedance is r plus jx. Both are 0, and hence the normalized impedance which is given by is equal to 0 means it is representing the short circuit line. So it is representing the short circuit line, and if you want to see, this is the r equal to 0. The r equal to 0 is cutting over here also, and x equal to 0. So someone can say that this point 1 is representing the D and B both. So D and B both we can a separate session. Okay, for double E, I will take the separate session. Now, at point B, this is the 1 plus J0. 1 plus J0, who will be representing 1 plus J0? R equal to 1. Let us say R equal to 1 will be somewhere here. This point is R equal to 0 and X equal, and this is X equal to plus 1. So at point C, if I talk at point C, the R is the size impedance is R plus jx that is J. So the normalized impedance will become ZL upon Z naught is equal to J. So ZL is equal to J Z naught. That means the pure uh, inductive element. So let us say 1 plus J00 plus 1. Huh? Okay, so which one will represent this? 1 plus J0 or 0 minus 1. So x equal to 1. So this one is representing the point C. This is representing the point C. This is the D and B. Okay, R equal to 1. Out of this, R equal to 1 is nowhere. Point number A, this point number, that means here the gamma is 0. Gamma is 0 means the load is equal to characteristic impedance. So the normalized impedance is equal to 1, and that is equal to R plus J0. So R plus Jx. So that means 1 plus J0. So the option number, this point number 2 is representing the A. So point A, point D and C and this. Now 0 minus J1, obviously this will be the point number E. Here if I observe this, that at point E, R is 0 and X is minus 1. Okay, so from here the normalized impedance is minus J. So load impedance divided by characteristic impedance is minus J. Load impedance is equal to minus J Z naught. So this is X equal to minus 1. So this one is representing the E. Now both are infinity at D, at B, sorry, at B, that we have already seen. And this is the point which is representing the A, matched condition where the reflection coefficient is 0 and there it will be minimum and maximum. So this will be the maximum impedance. Okay, maximum impedance you will get there where it is open means point B. So it would be at point B. Okay, so it would be at point B because here you can see that this is infinity point now. So here X is also infinite, R is also infinite. That means this is the condition of open circuited point where it is short circuited. So here it is short circuited. So in this way it is the point, the sixth one is point D. So in this way um, all the points in this particular Smith chart we have derived. Okay. Any point that I am left with? No. So point C we have derived here. Point D, this is the point D, point A, point E and point B. Point B is R equal to infinity, X equal to infinity. So you can say that your normalized impedance will be infinity plus J infinity. So the load impedance divided by characteristic impedance is equal to infinite. So ZL equal to infinity. That means it is open circuit. Okay, clear? So in this way you can represent all the points in the Smith chart. Now try to answer this. Try answering this question. There is again a Smith chart question. A 500-meter lossless transmission line is terminated by a load which is located at point P on the Smith chart. The A 500-meter lossless transmission line is terminated by a load which is located at point P, which is at minus 150 degree on the Smith chart. So if lambda is equal to 150 meters, that how many voltage maximum exist on the line? On there are five options given. 3, 4, 5, 6. No. 7, 6, 5, 3. Hello, hello. Yes. Getting my voice? So either 6 or 7 will come, na? See, See, now, are you able to listen it? Are you able to listen it now? Voice clear? Let me check. Yes, now voice is clear. So guys, I was saying, यहाँ तक आपको समझ में आया क्या? आयुष? ठीक है, इसकी जरूरत नहीं पड़ेगी, मुझे इसकी जरूरत नहीं पड़ेगी। ठीक है, मैंने क्या बोला कि लैम्डा बाई 2 मतलब 360 डिग्री, लैम्डा मीन्स 720 डिग्री। ठीक है, मैंने क्या बोला कि लैम्डा बाई 2 मतलब 360 डिग्री। ठीक है, लैम्डा बाई 2 मतलब 360 डिग्री रोटेशन होता है, और लैम्डा मतलब 720 डिग्री रोटेशन होता है। तो अगर लैम्डा में तुम 720 डिग्री रोटेशन कर रहे हो, मतलब अगर मैं 500 को 150 से डिवाइड कर रहा हूं, तो कितना आ जाएगा यहाँ से? 6 टाइम्स तो कंप्लीटली जाएगा और 50 मीटर बच जाएगा, है ना? जब 6 टाइम्स आप रोटेट करोगे तो ये 450 मीटर चला जाएगा। ठीक है, 450 मीटर जाएगा, बचेगा कितना? 50 मीटर बचेगा, राइट? यहाँ तक समझ में आया क्या आयुष? अब 50 मीटर बचेगा, मतलब लैम्डा मतलब 720 डिग्री है, तो 50 मीटर मतलब 720 डिवाइड बाय लैम्डा इंटू 50। लैम्डा की वैल्यू 150 है, तो इसको कैंसिल करोगे तो 240 डिग्री आएगा। तो 240 डिग्री जब आप यहाँ से ड्रॉ करोगे, तो 240 डिग्री वापस से पॉइंट पी से ड्रॉ करोगे तो 180 डिग्री ड्रॉ करोगे तो यहाँ तक आओगे। ठीक है, और ये वाला 30 डिग्री है, तो यहाँ पे भी ये वाला एंगल 30 डिग्री हो जाएगा। तुम 180 प्लस 30 करो, कितना आ गया? 210। और तुम यहाँ से और 30 डिग्री नीचे जाओगे, मतलब यहाँ पे पहुंच जाओगे पॉइंट क्यू पे। तो ये तुम्हारा पॉइंट पी से पॉइंट क्यू तक का एंगल हो गया 240 डिग्री। ठीक है, तो यानी कि आपने एक बार फिर से वोल्टेज मैक्सिमा को क्रॉस किया, तो पहले ही आप 6 टाइम क्रॉस कर चुके थे, और ये 240 डिग्री को रोटेट किए तो फिर से एक बार और क्रॉस कर गए, मतलब आप 7 टाइम्स क्रॉस कर गए। देखो, क्लियर हुआ ये? तो आंसर आ जाएगा 7। हाउ मेनी वोल्टेज मैक्सिमा एग्जिस्ट ऑन द लाइन? इज 7। आयुष, क्लियर हुआ क्या? बताओ, अगर इसमें अभी भी कोई डाउट हो तो बताओ, इसको क्लियर कर लेंगे। ठीक है, क्लियर हो गया? गुड। चलो इस क्वेश्चन को सॉल्व करो। बी आ रहा है? चलो चेक करते हैं। इट्स इलेक्ट्रिकल लेंथ।
देखो यहाँ पे मुझे कैलकुलेट करना है इलेक्ट्रिकल लेंथ। सो इलेक्ट्रिकल लेंथ कितना होता है? ये होता है तुम्हारा बीटा इंटू एल, है ना। इलेक्ट्रिकल लेंथ कितना होता है? बीटा इंटू एल। बीटा निकालना है तो लॉसलेस ट्रांसमिशन लाइन है तो ओमेगा रूट एल सी होगा। सो 2 पाई इंटू 30 इंटू 10⁻⁶ एंड रूट ओवर एल 10 इंटू 10⁻⁻⁶ एंड सी 40 इंटू 10⁻⁻12 ये आएगा। सो 2 पाई इंटू 30 इंटू 10⁻⁶ इंटू रूट में 10 इंटू 40 इंटू 10⁻⁻18। ठीक है, ये आएगा 3.76। सो हमारे पास ये आ रहा है 3.76 रेडियन पर मीटर। सो 3.76, अच्छा इसमें तो एक काम इसने ये कर दिया है कि लैम्डा के टर्म्स में निकाल दिया है। चलो देखते हैं हम, यहाँ पे मैंने लिख तो दिया है। तो ये 50/100 करोगे तो 2 आ गया, ये 1.88 आ रहा है ना। 1.88 आएगा रेडियन में। अब 1.88 को अगर मैं डिग्री में कन्वर्ट करूं तो ये आ रहा है 108। यस, 108 डिग्री। ये रेडियन है, इसको डिग्री में कन्वर्ट करो, 108 डिग्री है। ओके, 108 डिग्री आ रहा है, देख लो। मेरे अकॉर्डिंग मुझे ऐसा लग रहा है कि 108 डिग्री ही आना चाहिए। आपको क्या लग रहा है, देख के बताओ। ठीक है, या सिली मिस्टेक किए हो? ओके, यही होता है एक्चुअली एग्जाम में भी। इसीलिए आपको ये सारे सेशन जैसे बेसिक वाले अटेंड कर लेना चाहिए, जिसमें आपको आइडिया लग जाता है। चलो ये बताओ, इसका आंसर कितना आएगा? जो सिली मिस्टेक है वो अवॉइड करना है और उसी के लिए प्रैक्टिस करना है। जी आ रहा है। See, what is the distance between two maxima, adjacent maxima? The distance between two adjacent maxima. Distance between two adjacent maxima is given by लैम्डा बाय 2, और यहाँ पे इसकी वैल्यू कितनी है 25 सेंटीमीटर। सो लैम्डा इज इक्वल टू कितना आ गया 50 सेंटीमीटर, या हम बोल रहे हैं 1/2 मीटर। ठीक है, लैम्डा इज इक्वल टू सी बाई एफ होता है, तो 3 इंटू 10⁻8 डिवाइडेड बाय एफ इज इक्वल टू 1/2 आ गया। सो एफ इज इक्वल टू 6 इंटू 10⁻8 हो जाएगा, यानी कि 600 मेगा हर्ट्ज। यस, 600 मेगा हर्ट्ज इज द राइट आंसर। ठीक है, चलो इसको सॉल्व करो। Three lossless lines are connected as shown in figure, that in we have to calculate. Come on, three lossless lines are connected as shown. Input impedance means यहाँ पे आपको impedance sorry, -50। चलो इसमें एक थोड़ा सा मैं चेंज करता हूँ आपके लिए। लैम्डा बाई 8 एक्चुअली आया है ना, लैम्डा बाई 8 आया है, तो उसकी वजह से क्वेश्चन थोड़ा सा लेंदी दिख रहा है। चलो आप एक काम करो, यहाँ पे बताओ। ठीक है, आप बताओ पॉइंट बी पे बताओ, इसको छोड़ दो, या इसको हम लैम्डा बाय 4 कर लें, तो आप इन बता दो। ठीक है, 2 मिनट बचा हुआ है। यहाँ पे आप इसको 5 लैम्डा बाय 4 कर लो, 5 लैम्डा बाय 4 कर लो, अदरवाइज थोड़ा लेंदी हो जाएगा। 5 लैम्डा बाई 8 करेंगे तो हम लोगों को बीटा एल कैलकुलेट करना पड़ेगा, और बीटा की वैल्यू 2 पाई बाई लैम्डा से कैलकुलेट करना पड़ेगा। देखते हैं, रुको अभी सॉल्व करता हूँ मैं। जितना आपका हो गया है आप वहां तक नोट कर लो। बी तक आपका करेक्टली आया होगा, बी तक में तो कोई दिक्कत नहीं आना चाहिए था। और -50 तो राइट आंसर नहीं है, एक बार चेक कर लेते हैं। निगेटिव आंसर तो पॉसिबल नहीं है। इनपुट इम्पीडेंस कॉम्प्लेक्स में निगेटिव आ सकता है, जैसे कि मान लो 50 -j50 ऐसा आता, तो जो रिएक्टिव पार्ट है वो निगेटिव हो सकता है, रेजिस्टिव पार्ट निगेटिव पॉसिबल नहीं। ट्रांसमिशन लाइन में रेजिस्टिव पार्ट निगेटिव पॉसिबल नहीं, क्योंकि ट्रांसमिशन लाइन हम लोग सिर्फ और सिर्फ पैसिव एलिमेंट के लिए पढ़ते हैं। तो पैसिव एलिमेंट में जो रेजिस्टिव पार्ट है वो आपका हमेशा रियल पॉजिटिव होना चाहिए। ठीक है, रेजिस्टिव पार्ट निगेटिव नहीं होगा, अगर होगा तो फिर वो एक्टिव एलिमेंट हो जाएगा। देखो सबसे पहले लोड इम्पीडेंस दिया हुआ है लैम्डा बाय 2 लेंथ है ना, तो फॉर लैम्डा बाय 2 लेंथ ट्रांसमिशन लाइन, फॉर लैम्डा बाय 2 लेंथ ट्रांसमिशन लाइन, अगर मैं यहाँ पे कैलकुलेट करूँ ZC सपोज, तो जो ZC है वो ZL के बराबर होगा, क्योंकि लैम्डा बाय 2 लेंथ के ट्रांसमिशन लाइन में हमारा जो भी लोड इम्पीडेंस होता है वो एज इट इज कॉपी हो जाता है इनपुट पे। ठीक है, इसमें कोई डाउट? 60 माइनस J35 ही तुम्हारा इम्पीडेंस आ जाएगा सी पॉइंट पे, जो कि लोड का काम करेगा 3 लैम्डा बाई 4 के लिए। हाँ, अब 3 लैम्डा बाई 4 एक क्वार्टर वेव बन गया। ठीक है, 3 लैम्डा बाय 4 वाला हो गया क्वार्टर वेव। अब ये वाला क्वार्टर वेव के लिए इनपुट इम्पीडेंस बी पे निकालते हैं, तो बी पे जब इनपुट इम्पीडेंस निकालोगे तो वो हो जाएगा Z0 स्क्वायर अपॉन ZL। सो 100 इंटू 100 डिवाइडेड बाय लोड, लोड हो गया 60 माइनस J35। सो इसको आपको पहले 60 प्लस J35 एंड 60 प्लस J35 करके सॉल्व करना होगा। ठीक है, सो इसको अगर हम लोग सॉल्व करते हैं तो यहाँ से हमारे पास 60 का स्क्वायर प्लस 35 का स्क्वायर आ जाएगा। ठीक है, 60 का स्क्वायर प्लस 35 का स्क्वायर। ठीक है, तो 4825 आ रहा है डिनोमिनेटर में, तो इसको मैं लिख लेता हूँ 10 टू द पावर 4 60 प्लस J35 डिवाइडेड बाय 4825। सो 60 into 10 to the power 4 डिवाइडेड बाय 4825 करने पे आ रहा है 124। ओके ओके, ठीक है, 124.35 प्लस जे, यहाँ पे एक बार मैं इतना यही तक निकाल लेता हूँ बस। ठीक है, 35 इंटू 10 पावर 4, सो जे 72.5, ये जो है इनपुट इम्पीडेंस एट बी आ जाएगा। इसके बाद तो आप लैम्डा बाई 8 के लिए निकालोगे, तो बीटा एल अगर हम निकालेंगे तो ये 2 पाई बाई लैम्डा इंटू लैम्डा 5 लैम्डा डिवाइडेड बाई 8, लैम्डा लैम्डा कैंसिल, सो ये आ जाएगा 5 पाई बाई 4। 5 पाई बाई 4 कितना होता है? 225 होता है ना, तो उसके लिए फिर हम लोग को इनपुट इम्पीडेंस का फॉर्मूला सब्स्टिट्यूट करके कैलकुलेट करना पड़ेगा। वो हो गया Z0 ZL प्लस J10 बीटा L इंटू Z0 डिवाइडेड बाय Z0 प्लस J ZL 10 बीटा। ठीक है, तो इसमें सब्स्टिट्यूट कर देंगे, लोड आ गया हमारा ये वाला ZB, तो ZB हमारा इस पे लोड का काम करेगा और कैरेक्टरिस्टिक इम्पीडेंस ये है, और Zin हमको कैलकुलेट, 10 बीटा L 1 कैसे आएगा? 5 लैम्डा बाई 8 है ना। चेक करो आयुष, बीटा एल 1 कैसे आएगा? यहाँ पे 5 लैम्डा 5 पाई बाई 4 है, 5 लैम्डा बाई 8 है। ठीक है, तो इसमें सब्स्टिट्यूट कर लेंगे, फिर आपका आंसर आ जाएगा, और फाइनल आंसर आना चाहिए आपके पास 5 प्लस 5 बाई 4। नहीं, वो 5 बाई 4 नहीं है ना, पाई/8 है। एक्चुअल क्वेश्चन में पाई/8 है, मैंने आपको 4 लेने बोला था। 4 लेने से तो वो Z0² अपॉन ZL बन जाएगा ना। 4 अगर मैं लेने बोला था वैसे आपको, 5 पाई/4 तो तुम्हारा, हाँ 10 to 25 होगा ना, 10 to 5। हाँ वो 1 आ जाएगा, ये 1 आ जाएगा, ठीक है, ये तो 1 आ जाएगा। 5 पाई/4 ये 1 आ जाएगा, तो ये 1 आ गया, मतलब ये वाला पूरा पार्ट हट गया। ठीक है, ये वाला पूरा पार्ट हट गया, ये 1 आ गया। तो मतलब अब आपको इसमें सब्स्टिट्यूट करना है। तो मतलब आपका जो क्वेश्चन हो गया वो ZL प्लस JZ0 प्लस Z0 प्लस JZL, ऐसा बोल रहे हो ना। ठीक है, मैं सोच रहा था कि तुम बीटा एल को 1 बोल रहे हो। ठीक है, मतलब मैं उल्टा सोच रहा था। ठीक है, अब इसमें आपको वैल्यू सब्स्टिट्यूट करना है। ये आपका वो वाला केस हो गया λ/8 वाला। तो λ/8 में इतना आता है। अब अगर मान लो Zin का मैग्नीट्यूड निकालना होता तो कैरेक्टरिस्टिक इंपीडेंस 50 के इक्वल हो जाता, बट क्योंकि मुझे ये पूरा पार्ट निकालना है तो ZL मैंने निकाल दिया, ये वाला पूरा। और ZL हो गया, Z0 की वैल्यू 50 है। इसको पूरा सॉल्व कर लेंगे तो हमारा आंसर आ जाएगा। ठीक है, सो गाइस देयर इज ए ओपन मॉक टेस्ट फॉर ऑल ऑफ यू, है ना। ये फ्री ऑफ कॉस्ट एक ओपन मॉक टेस्ट आपका चल रहा है, उसको आप डिस्क्रिप्शन में दिए हुए लिंक से ज्वाइन कर सकते हैं। दिस इज अवर नेक्स्ट क्वेश्चन। टू आइडेंटिकल एंटीना क्वेश्चन, डायग्राम नहीं बनाया है इसने। ओके, इसने डायग्राम नहीं बनाया है। चलो मैं आपको डायग्राम दे रहा हूँ। 1 मिनट एक्स्ट्रा मैंने डायग्राम के लिए रखा है। डायग्राम एक बार मैं चेक कर लेता हूँ क्या डायग्राम है। डायग्राम क्वेश्चन क्या था अपना? Two identical antennas, 74 ohm are found. Yes. So डायग्राम एक्चुअली दोनों क्वेश्चन का सेम है। यही डायग्राम है। इसका मैं स्क्रीनशॉट ले सकता हूँ। चलो एक बार इसमें चार्ट नंबर ऑफ मैक्सिमा वाला फिर से वो, मतलब रिपीट करने बोल रहे हो उस क्वेश्चन को। वन फोर एट जीरो 1480 तो नहीं है, थोड़ा सा कैलकुलेशन मिस्टेक है लग रहा है। कैरेक्टरिस्टिक इम्पीडेंस 50 है। 1480. Have you checked the answer, Ayush? Yes, 148. Now it is correct. 148 is the right answer. So anyone else who want to answer this question? See, this is the lambda by 4 length transmission line. This is also lambda by 4 length transmission line. These two are connected in parallel. So we know that for the lambda by 4 length transmission line, okay, the input impedance is given by Z0 square upon ZL. So according to this, if I calculate here, so Z in 1 is Z0 square, which is 50 whole square divided by 74, and this is same for the second one also. So Z in 2. So Z is in parallel with 50 whole square divided by 74. It is coming as 33.78. So 33.78 in parallel with 33.78. So that is nothing but half. So it is 16.89. And now input impedance is again Z0 square upon ZL, which is 16.89. So it is coming as 140. Okay. Calculate the average power delivered to the either of the antenna. Calculate the average power to either of the antenna. The same problem, na? So input impedance now we know. 5 milliwatt. Okay, so see, first of all, the input impedance we have calculated. So the input impedance is 148. So what is the current? The current is the voltage at the input side divided by input impedance plus Zg, the generator impedance, that is 80. So V in is 120 divided by 148 plus 80. So how much is the current? So it is 0.526. 0.5263 ampere. Okay, this is the current. Now, what is the power? The power at the input of this transmission line is 1 by 2 V in into I in. Okay, or you can say I in square into R in. Okay, or you can also write 1 by 2 I in mod square into R in. So 1 by 2, 0.5263 whole square, and R in input impedance we have calculated as 148. So square into 148 divided by 2. We have got 20.5 watt. So 20.5 watt power we are giving to the transmission line. This transmission line we are giving how much? 20.5. And this transmission line is lossless. Since it is lossless, so it is reaching to this point. So here also 20.5 will be delivered to the load, and then it is equally divided into the two. So average power delivered to either antenna will be 10.25 and 10.25, because the transmission line is lossless. Okay, the transmission line is lossless. So here it is given the transmission line is lossless. So because the transmission line is lossless, the power which you give at the input will be completely delivered to the load. And in this transmission line, in the first transmission line, the load is another transmission line. So there are two transmission line connected in the load of the first transmission line. So in each transmission line, 10.25 will be delivered, and all the transmission lines are lossless. So 10.25 will be completely delivered to the antenna. Okay. Okay. Now answer this one. Ayush, because it is a peak value, no? We write in terms of VRMS into IRMS. Then in terms of peak value, when we write VRMS is equal to V naught divided by root 2 and then whole square. So I square into R. So that I is nothing but IRMS square. Okay, IRMS is converted into the peak value. So that is why I naught divided by root 2 whole square will come. So that is why I naught square divided by 2 came. 800 open circuit and 3200. Okay. Hmm. Let me check the answers. Uh, 200. Why? Okay, yes. You have done again mistake now. 2500 divided by 200. 12.5 it should come, and that is open circuit is correct. And for the third line, it is 12.5 only. So 12.5. So 2500 divided by 12.5. 200. Okay, so here for the line 1, this line 1, this is the lambda by 4 length transmission line. So definitely this is Z in 1 is equal to Z naught square upon ZL. So this is 50. So 50 is means 2500. Okay, 50 whole square is 2500 divided by 200. So we will get 12.5. And here the Z in 2 will be same Z naught square upon ZL because it is short circuited. So it will be open circuited, that is infinity. So to calculate the input impedance at 3, it will be in here it is the parallel combination. So the load will become the here the load will become the parallel combination of Z in 1 and Z in 2. So it is nothing but the infinity in parallel with 12.5. So that is nothing but a 12.5. So Z naught square means again 2500 divided by 12.5. So it is equal to 200. So that is the answer. 200 infinity and 12. Okay, so now this is the question from the waveguide. Yes, an air-filled 5 by 2 cross 5 by 2 centimeter square waveguide has EZ at 15 megahertz, then what mode is being propagated and what is the value of beta? Come on, guys, this is the last question for today's session. So, if you can solve this, then in the next session, we will discuss the questions of waveguide and antenna. Today, we solve the questions of the transmission line and followed by the waveguide, and this is the waveguide question. And after that, we will solve the waveguide followed by antenna questions. Okay. So, there are two type of mode possible in the waveguide. Okay, there are two type of mode possible in the waveguide. First is known as the transverse magnetic mode. That means Ez will not be equal to 0 and Hz will be 0, and in that case Ez is given by E naught, and you can say the sine m pi by a into x in general and sine n pi by b into y. Okay, and e to the power minus j beta z. And another mode is the transverse electric mode, and in the transverse electric mode Hz is not equal to 0 and Ez is equal to 0. So Hz is equal to H naught cos m pi by a into x and cos n pi by b into y, e to the power minus j beta z. Okay. So Here you can see now this cos m pi by ax and cos m pi by by e to power minus j beta z. These are the two different got expressions we have got. Now if you compare, you can clearly see this is matching with our TM mode. So this is for sure that which mode will be propagated, then the TM mode will be propagated. Now which mode exactly the number that TM mode will be propagated, but what is the value of m and n? So to get the value of m and n, we will compare this. Again, I am taking this part there. Okay, so I'm using this. So here if I compare, I'm getting m pi by a is equal to 40 pi. So this pi and pi will get cancelled and m equal to 40a. So a is 5 centimeter. So 5 into 10 to the power minus 2 into 40. So this is 2. M equal to 2 and n pi by b equal to 50. So n is equal to 50 into b, and 50 into b. B is how much? 2 centimeter. So 2 into 10 to the power minus 2. So n equal to 1. So you are getting n equal to 1 and m equal to 2. That means Tm 2-1 mode. Okay, so this is the first answer of the first question. Now you want to calculate the beta, but because you have got this mode, now you can calculate the cutoff frequency as well. So cutoff frequency is given by Fc is equal to Vp upon 2 root over m upon a whole square plus n upon b whole square. What is Vp? Vp is, because this is air field, so it is C. So this is 3 into 10 to the power 10 divided by 2. I am writing in centimeter. M is 2, A is 5, and N is 1, and B is 2 whole square. So now if I calculate it, I will get root over 4 upon 25 plus 1 by 4.64 into 1.5 into 10. 9.6. 9 point, yes, 9.604. So we are getting 9.604 gigahertz. So this is the cutoff frequency we are getting. Now we want to calculate the value of beta in the second part. So beta is nothing but beta g guided wave, beta root over 1 minus fc upon f whole square. So this is omega by c and root over 1 minus fc. Omega you can calculate now, 15 gigahertz, and f is also 15. So 1 minus 9.6 upon 15 whole square, and this can be written as 2 pi into 15 into 10 to the power 9 divided by 3 into 10 to the power 8 root over 1 minus 9.6 divided by 15 whole square. This is minus. Now if I calculate it, then 2 pi into 15 into 10 to the power 9 divided by 3 into 10 to the power 8 root over 1 minus in bracket 9.6 square divided by 15 square. We are getting 241. 241.3. 241.3. So beta G is 241.3. So I am writing here answer 241.3 radian per meter. This we will get, and this we have got TM21. This is our answer. Okay, now coming to the last part of this EY and EZ. So how can you calculate the EX? EX is nothing but the minus gamma upon H square DEZ upon DX minus J omega mu upon H square DH. Okay, so Ez is there. So minus gamma upon H square del upon del x of Ez is given 20 sine 40 pi. So 20 sine 40 pi x into sine 50 pi y e to the power minus j beta z. And this hz is 0. Hz is 0 because it is Tm mode. So minus gamma upon h square into 40 pi into 20 cos 40 pi x and then sine 50 pi y e to the power minus j beta z. This is EY, EX. Now we have to calculate EY. What is EY? Minus gamma upon h square del EZS upon del y minus del j omega mu upon h square del hz upon del x. Okay, then what we need to calculate EY upon EX. So because it is, we have to differentiate it with respect to y only. So now this time it is 20 sine 40 pi x into 50 pi into cos 50 pi y into e to the power minus j beta z. This is equation number 1 and 2. If I divide it EY upon EX, then this minus gamma upon h square will get cancelled, and cos upon sine is cot, and sine upon cos is 10. So 20 into 50 pi, these are the constant, and cot of 50 pi y and 10 of 40 pi x. Exponential term will also get cancelled, and this is 40 pi into 20. So 20 and 20 also get cancelled, pi also get cancelled. So we are getting 5 by 4, 10, 40 pi x and cot of 50 pi y. Okay, you can, it may be not written to you, but seen to you, but it is understandable. 1.25, 10, 40 pi x and cot 50 pi y. Okay, so this will be the answer for this particular question. Any doubt in this? Anyone having any doubt in this? Okay, so guys, this is it from my side today, and we will solve more questions on our next class, that will be on Friday. And note that there will be a class on next Friday at 7 p.m. Friday 7 p.m. we will be solving the questions of antenna and waveguide. So guys, we have launched already the course for the GATE 2025 and 2026. So if you are interested to join the GATE full course, whether it is a Hindi language or English language, you can enroll in our particular batch, and you can call us on this number to book an appointment, and you can get the counseling, that what is required, what are the benefits of GATE, how we are going to help you in your profession, what are the things we are providing apart from your live classes. So we will provide the recorded lecture, study material, etc. So you can have whatever query in your mind, you can ask them, in this, calling in this number. And there is a scholarship test also. So the 90%, up to 90% scholarship test you can avail. You can give the test of scholarship test on the upcoming Sunday, 19th of November, and from morning 9 a.m. to 9 p.m. And the link is given in the description. And there is a 1 year plan to conquer the Gate 25 by the Rakesh sir on 22nd of November at 7:30 p.m. And this is my Telegram group where you can join and connect with me. Okay. And thank you for watching this particular session and staying with me for 1.5 hours and solving the questions of EMFT. Don't forget to subscribe the channel. Don't forget to download our BYJU'S exam prep app, because in the app also we run many free sessions. Okay. Thank you.